this video, we're going to go over how to name ionic compounds that contain polyatomic ions. And so before we get into the naming, I do want to just go over some of the more common polyatomic ions that are found. I have created a cheat sheet of these polyatomic ions that you can gain if you want to. I've included the link in the description below, so go grab it if you want a useful reference sheet as you're kind of working through some of the polyatomic nomenclature naming. Okay, so that being said, I've kind of split this up into the valences for different polyatomic ions, so we can go through those. Starting off with a valence of -1, there are several different polyatomic ions with a valence of -1. So things like nitrate or any of the ones with halogens. So chlorate, bromate, iodate, fluorate, they're all just differing by a halogen here. We've got hydroxide, acetate, permanganate, cyanide and thiocyanate. And then we've got all of our bi sort of stuff. So we got a hydrogen carbonate, or it's sometimes called bicarbonate. We have a dihydrogen phosphate or a hydrogen sulfate or bisulfate. So all of these are a -1 valence. The only one with a +1 valence that's pretty common is ammonium. So that's NH4+, and that one does come up quite often. There are a few less polyatomic ions that are common with a valence of -2. So these ones and the ones I'm going to focus on in this video here are carbonate and sulfate. There's also chromate and dichromate, which do come up quite often, especially in electrochemistry. They're very good in terms of doing some redox reactions, which I'll talk about in another video. There's also peroxide, which is O2 2-, and then hydrogen phosphate or biphosphate, which is HPO4 2-. And then finally, the only one that I'm going to focus on with a valence of -3 here is the phosphate polyatomic ion. So like I said, I have a cheat sheet, reference sheet down in the description below if you want to get that, or you can kind of jot those down all for your notes. Sometimes you might have to memorize them, sometimes you'll be given the formulas, so kind of depends on your situation. Now, if you do need to memorize the polyatomic ions, there's a great sort of saying you can use to help you memorize some of the really common polyatomic ions, and that is Nick the camel ate a clam supper in Phoenix. And you might be going, what the heck does this have to do with nomenclature? Well, you can use this in that the 8 tells you that these are all the polyatomic ions that end in the ending 8. So like it might be nitrate, chlorate, carbonate, sulfate, and so on and so forth. And then each of the words that I have colored here, so Nick, camel, clam, supper, and Phoenix, all help you to remember what the formula is for one of the common polyatomic ions. The first letter represents the element that the polyatomic ion starts with. So Nick starts with N, right? Camel, this is for the carbon. The clam is chlorine, the S is for sulfur, and then the P is for the phosphate. The number of consonants, so that's non-vowel letters, so everything other than A, E, I, O, U. The number of consonants tells you how many oxygens are in that polyatomic ion. So in Nick, we have N, C, and K. So there's 3, which means it's an O3, right? Camel has C, M, and L. So that's an O3. Clam has C, L, M. That's an O3. Supper, S, P, P, R. So that's an O4. And then Phoenix, P, H, N, X, that's also A4. The number of vowels tells us the charge. So we have 1 vowel here, so that it's NO3 1-, and that is our nitrate ion. For the carbonate, we got 2 vowels, so that's a 2-. For chlorate, we got 1 vowel, -1. For supper, we have 2 vowels, so it's a 2- for the sulfate, and then 3 vowels here for Phoenix, so that's a -3 charge. So it's a nice like mnemonic device, acronym, whatever you want to call it, that can help you memorize some of the really, really common polyatomic ions. And then for this one here, the chlorate, you can substitute any of the halogens there and you'll get the same formula for those as well. So kind of nice. It expands how many of these different ones to make it really easy to memorize. Okay, so now that we're through with all the memorizing stuff, let's actually get into the naming. And the naming is relatively easy. So if we're going name to formula, we're going to write the symbol of the metal, and it's going to be followed by the symbol for the polyatomic ion. We're going to write the valences above each, and then crisscross the numbers down to the subscript position. And we have to make sure we use brackets if there's more than one of the polyatomic ion. And then finally, reduce the formula or remove any subscripts of 1. So let's take a look at some examples and see how this works. Our first example here, calcium nitrate. Okay, so calcium Ca and nitrate is NO3. Calcium's a +2, nitrate's a -1. We're going to crisscross those numbers down. Okay, so that give a calcium 1 and give it the nitrate 2. And because we got more than one polyatomic ion, we're going to have to use brackets. Okay, so the final formula for this is going to be Ca bracket NO3 bracket 2. Okay, if you didn't include the brackets here, it would look like you had 32 oxygens, which does not make sense. So do not do that. Okay, the next one, iron 2 phosphate. So iron, the 2 in brackets tells us it's a +2, and then phosphate, PO4, is a -3. We're going to crisscross those down. So we have 2 phosphates and 3 irons. So that's going to give us Fe3, and then we need the brackets, PO4, 2. And finally, ammonium chloride. Okay, so be aware, sometimes your polyatomic is first. So we're going to write our NH4, that has a +1. Chlorine's a -1. So crisscrossing down, we just get 1 and 1. So that's going to become NH4Cl. Now, going in the opposite direction, going formula to name, what we're going to do is write the name of the metal, followed by the polyatomic ion. And then if the metal is multivalent, we also have to include the valence as a Roman numeral as well after the name of the metal. It's fairly straightforward to name these because, you know, they're just sort of identifying the polyatomic, identifying the metal, and putting it all together. All right, so let's take a look at this. We got aluminum and we got carbonate. So we're going to go aluminum. Now, aluminum is not multivalent, so we don't have to worry about that. And then our polyatomic is carbonate. So this is aluminum carbonate. Carbonate. Easy, right? Okay. Next one, KMnO4. So K is potassium. And then MnO4 is permanganate. So this is potassium permanganate. Manganate. There we go. And then finally, Na2Cr2O7. So Na is sodium. And then we need to recognize Cr2O7 is dichromate. So that is sodium dichromate. So that is how easy it is to name compounds that contain polyatomic ions. So we've gone through some of the common polyatomic ions. We've gone through both name to formula and formula to name. That's it then for this video. We'll see you in the next one.